Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. It's me again, Teacher Kent. I'm sorry, class. The truth is, I really miss all of you. But sadly, because of COVID, I don't think I can see you this week. I think I might be able to see all of you starting July 1. But no matter, don't worry, we will still continue learning. I still want all of you to learn more about science. Now, our topic last week was about the fun facts about electricity and simple electric circuits. Now, I was thinking, why should you know the fun facts if you don't even know where electricity comes from? So, today I'm going to tell you how electricity was evolved, adapted, and not invented. Are you ready? Let's start. The history of electricity. Let me just make my face a little bit bigger. There you go. Okay, first things first. Nobody actually invented electricity. Electricity was there even before humans started to use it. But electricity was generated by humans once we have a proper understanding of it. And how did we get a proper understanding? By a process that took thousands of years. You don't believe me? Let's go on the history of electricity. The shocking history of electricity. Around 600 BC, Greeks found that by rubbing a hard, fossilized resin called amber against a fur cloth, it would attract particles of straw. This strange effect remained a mystery for over 2,000 years. For those of you who don't know, the Greeks and the Romans, they invented a lot of what is known today in modern science. The Greeks, they found that if they rub a fossilized resin called amber against a fur cloth, it would attract some particles of straw. They just discovered that. However, they did not take advantage of it because they didn't know what to make of it. Back then, they didn't need any lights. The only light they needed was the moonlight, the sunlight, and the light from fire. So, after many thousands of years, 2,000 years to be exact, around 1600, William Gilbert, a physician who lived in London at the time of Queen Elizabeth I and Shakespeare, studied the attraction produced when materials were rubbed and named it the electric attraction. From that came the word electricity, and all others derived from it. So, this guy, William Gilbert, he named electric the attraction when two materials are rubbed and you try and touch another thing. Sometimes some materials will suddenly go to your object, to the thing that is rubbed. He just studied it. He didn't discover electricity yet. He discovered, I think, what we call now as static electricity. He named it electric, and that's where we got the name electricity from William Gilbert. Let's continue. The birth of electronics. During the 1800s, it became evident that electric charge had a natural unit, which could not be subdivided any further. And in 1891, Johnston Stoney proposed to name it electron. When J. Thomson discovered a particle which carried that charge, the name electrons was applied to it. He won the Nobel Prize in 1906 for his discovery. So this guy, this person, John Stone Stoney, named electron or discovered electron. It may be funny how we know it. We can read it in books nowadays, but back then, this discovery was so amazing that he was given the Nobel Prize. And if you don't know what a Nobel Prize is, it's what scientists would love to achieve. It's what they're working towards. Because if you're given a Nobel Prize, that means you have done something amazing in the world of science. Benjamin Franklin in 1752. Franklin proved that lightning and the spark from amber were one and the same thing. The story is a familiar one, in which Franklin fastened an iron spicetto, a iron spike, to a silken kite which he flew during a thunderstorm while holding the end of the kite string by an iron key. When lightning flashed, a tiny spark jumped from the key to his wrist. The experiment proved Franklin's theory, but was extremely dangerous. He could have easily been killed. Benjamin Franklin. Oh, I'm sorry. I noticed that the name is broken. Sorry. There is supposed to be a B there. His name is Benjamin Franklin. He had a theory. Remember the steps of scientific theory? The first thing is the hypothesis. He had hypothesis. His hypothesis is the lightning that comes out in the sky during rain is the same spark when you rub something from amber. And what did he do? He experimented. How did he experiment? He used a kite, a silk kite, with an iron spike and a key during a thunderstorm. Now, for those of you who don't know, thunder usually hits the tallest thing in an area. Now, when Benjamin Franklin was flying his kite, he flew it so high that it became the tallest thing in that area. And because it had a spike in it and a key dangling from it, it allowed the electricity to hit the kite. And it allowed not just the kite, but the key. But thankfully, the the what do we call this? The rope did not allow much electricity to pass. Of course, Benjamin Franklin got a little shocked, but not very dangerous. However, I would not recommend this to you if you want to try this at home. You might get hurt. Remember, when you get shot by an electricity from lightning, there's a good chance you will be burned all over your body. Benjamin Franklin was just extremely lucky. Let's continue. Galvani and Volta. This person right here is Luigi Galvani. What did he do? Well, in 1786, Luigi Galvani, an Italian professor of medicine, found that when the leg of a dead frog was touched by a metal knife, the leg twitched violently. Galvani thought that the muscles of the frog must contain electricity. In 1786, once while Galvani was dissecting a frog, When you go to Matayom, I think you will also have an experiment while you need to cut open a frog. That because that's what I did when I went to my high school. When he touched the metal frog with no, sorry, when he touched the frog with his metal knife, I mean, the leg twitched violently, and he thought that perhaps there could be electricity that is causing this. In 1792, another Italian scientist, Alessandro Volta, I will show his picture on the next slide, disagreed. He realized that the main factors in Galvani's discovery were two different metals, the steel knife and the tin plate, upon which the frog was lying. Volta showed that when moisture comes between two different metals, electricity is created. This led him to invent the first electric battery, the voltaic pile, which he made from thin sheets of copper and zinc separated by moist pasteboard. So, this person, his name is Alessandro Volta. He said to Galvani, I'm sorry, but I think you're wrong. I don't think frogs have electricity. I think it's because of the copper thin you use to lay the frog on and your metal knife. Then, to prove his theory, he did just that. He got two different metals, tried to make, tried to pull them all together. A lot of metals he tried until he found the ones that proved his theory right. And how did he do that? He made a battery. It was the first ever battery. In this way, a new kind of electricity was discovered. Electricity that flowed steadily like a current of water instead of discharging itself in a single spark or shock. Volta showed that electricity could be made to travel from one place to another by wire, thereby making an important contribution to the science of electricity. The unit of electrical potential, the volt, is named after him. Oh, I think you've heard this before. If there when it comes to batteries, the first thing you will be asked is how many volts of a battery do you want? So the word volt came from Alessandro Volta, who was able to create the first ever battery. And then he discovered that the electricity can flow like water on a specific area. You can make it travel from one place to another. And that's amazing because during this time, people thought that even if they discovered electricity, they can't control it. But this person, Alessandro Volta, he not only showed that you can control electricity, you can make an object that can help control it. Isn't that amazing? We're now going to Michael Faraday. The credit for generating electric current on a practical scale goes to the famous English scientist Michael Faraday. Faraday was greatly interested in the invention of the electromagnet, but his brilliant mind took earlier experiments still further. If electricity could produce magnetism, why couldn't magnetism produce electricity? This person is very good because he found out about electromagnetism, which is when you put electricity into a magnet, the magnet becomes like a supercharged magnet. It can attract more metal. He was thinking, if the electricity can produce magnetism, why couldn't a magnet make an electricity? Right? It's like if he can make this, could it also make this? That's amazing. In 1831, Faraday found the solution. Electricity could be produced through magnetism by motion. He discovered that when a magnet was moved inside a coil of copper wire, a tiny electric flows through the wire. Of course, by today's standard, Faraday's electric generator was crude and provided only a small electric current, but he had discovered the first method of generating electricity by means of motion in a magnetic field. So, what did Michael Faraday discover? Michael Faraday discovered the first ever generator. You can make electricity using magnets. Think about that. Michael Faraday helped us find a way to make our own electricity. He made his own generator. Electric interaction at a distance. Faraday also realized that the electric force is transmitted by an electric field. Oh, if it's positive, it repels, and if it's negative, it attracts. That's why in batteries there are two poles, the positive and negative. In order to make an electric field, it has to be connected, the negative and the positive. Michael Faraday gave us the generator. Volta was able to teach us that electricity can travel to one place to another, like a waterfall. Benjamin Franklin found out that lightning is the same as the electric spark found when ancient Greeks rub amber on a fur coat. That's why I say you don't discover electricity. We evolved electricity. We made electricity a force of nature into a force of man. So that's it. We will continue this next meeting. I will see you on Friday. Goodbye.